Hey guys, Nico's here and welcome back to another episode of this real-time strategy game series. So we have our JavaScript code for the client in this client folder now, and then we have the server-side code which will serve up the client. Now in order to start the server, the node server, to serve up the files, we just do npm start and it'll serve up the game on localhost 3000. There we are. And what I want to talk about in this video is the select units. So what you normally do in a real-time strategy game is you can either click on individual units and things will move around, or you can drag and select. So what you can do here now is you can draw a rectangle over the units and they will move around altogether. And they can all shoot things. So I just want to talk about the code that is responsible for the unit selection in this video. So in our game class here, we have some handlers for mouse clicks on the page. So when we click mouse down on the game, we get the start position of where the mouse is clicked on the screen, and then we add an event listener for mouse move. So when we click on the page, we start the listener, and as we move, we're drawing a rectangle like this. So the on pointer move. The reason that we're using a bind function is that so we can then remove this function later when we do the mouse up. So on pointer move, so we start by getting the current position of where the mouse is, and we assigned it to the end position, and then what we do is we found out the width and height of a rectangle with the difference between the start and the end position, and we clear any current rectangle on the screen. What we're doing is we're actually rendering a rectangle on top of a 2D canvas, which is on top of the actual 3D canvas. It's kind of easier to just work with the 2D canvas by itself rather than trying to draw 2D objects on the 3D canvas. So here's the 3D canvas, here's the game overlay canvas, which sits on top of the 3D canvas. And I've given this a Z index of 1000 just to make sure. This is where we're actually drawing all the rectangles. So based on some of the settings for how you want the user selection or the unit selection rectangle, we decide to draw the rectangle based on those settings. And we want to ignore accidental mouse moves. Okay, and when we do mouse up, we remove the mouse move listener. And then we clear the currently selected rectangle. And once we have these dimensions of the rectangle that is drawn, we then call this method here, which then goes and finds what units are selected in this rectangle. So we have a helper here which checks to see if a point in the Babylon game is under the rectangle. Basically, I copied and pasted the selection code from Stack Overflow. You're welcome to go and discover more about that. I also want to cover the code for the core class, which is the main unit that we're moving around on the screen. Now, the core class extends the iGame unit, which has a number of methods that every game unit must implement as an interface. So there is a group ID, which I'll use later for when a user can create groups of units. There's mass, weapon, which is a laser, and there's a select methods and deselect methods, hit points, and a mesh, which is the mesh which contains the graphics or how it looks on the screen. So in terms of the core itself, we can see the implementation and declarations of some of these variables of the interface. And when we create a unit, we assign it to the actual Babylon scene, and we have initial properties. Like for example, if the mesh is the players, then we assign it a different color. all these things can be made more flexible, and when we make the real application, we assign its mesh and an action manager which can do things when the unit is clicked on. And there's like a select mesh method, which is the moment we're just surrounding the mesh with a bounding box. Deselect, we remove the bounding box. And we have some things like, will it take damage, taking hit points, and the current speed of the unit. And that's pretty much all there is to it. Quite simple at the moment. In terms of the server, well, when Webpack, the Webpack config here is taking the client and it's bundling it into the server public folder, into here. So in terms of the server rendering the app, at the moment we're serving up the express static of the public folder. Later on we will be talking about how to share world variables and state between multiple clients connecting to this game. And also we'll have to render on the server side the animation, so I will be talking about that. Thanks for watching another episode of this RTS game series, and see you next time. Bye.